it's endgame for NASA's Swift telescope as its rescue mission fails. China's ZhuQue-3 sticks the landing in another win for reusable rockets, even if it didn't stay vertical for too long. We see the results of a SpaceX rocket making an impact on the moon, and Ukraine makes an impact of its own on Russia's launch capabilities. As always, we've got all that and more coming up this week in Spaceflight. Chinese launch provider LandSpace scored a significant milestone this week when the first stage of its ZhuQue-3 successfully touched down on its landing pad in the Gobi Desert. The rocket joins an elite group of orbital-class boosters that have successfully returned to Earth for recovery and reuse. This group includes, of course, SpaceX's Falcon 9 and Falcon Heavy, which have been flying and landing for over 10 years now. Just days before, the company passed its 650th Falcon landing. That group also includes Starship, New Glenn, and most recently, the Changzheng 10B, which was successfully caught by a net system at sea, China's first booster recovery. With New Glenn also landing on Blue Origin's offshore drone ship Jacqueline, this makes the ZhuQue-3 the second orbital-class vehicle to propulsively land back on solid ground. And it was close to a bullseye, perfectly navigating towards its target, just as the rocket's maiden flight did back in December, though that flight just missed making history when an engine failure during the landing burn caused it to crash to the ground. But this time, everything went perfectly on its second flight. The rocket launched on August 19th from the Zhochuan Satellite Launch Center, successfully deploying a prototype communications satellite into low Earth orbit. After stage separation, just over 2 minutes into flight, the booster flipped and performed a 3-engine reentry burn at an altitude of 80 kilometers. Like Falcon 9, it used 4 grid fins to guide the stage back through the atmosphere towards the pad around 390 kilometers downrange. Those 3 engines were then relit for the landing burn around 3 or 4 kilometers from the ground, with the 4 legs folding out for the final 70 meters of descent. And as you can see, the ZhuQue-3 absolutely stuck the landing. That said, the stage does appear to have tipped over sometime after landing, according to posts on social media, though nothing has officially been said about this as of recording. But well, we don't really need an official statement to prove that this thing tipped over. LandSpace had been hoping to refly this specific booster within the next 6 months or so, but that's unlikely now. Despite the tip over, they still did land this booster, and beefing up the landing legs is a much easier process than figuring out how to land the thing in the first place, so the difficult problem has been solved. Like Starship and Terran R, the ZhuQue-3 is constructed of stainless steel. It's powered by 9 Tianche engines burning liquid methane and liquid oxygen. LandSpace also sent the world's first methane-powered rocket into orbit back in July of 2023 with the vehicle's predecessor, the ZhuQue-2, even beating the likes of Starship and New Glenn to that milestone. It's similar in size to the Falcon 9, a little shorter at 66 meters, but wider at 4.5 meters in diameter, and while it currently only offers about half the payload to orbit at around 8 tons, the next evolution, the ZhuQue-3E, will compete more directly. This will feature upgraded engines on both stages, extending the vehicle by 10 meters with a longer fairing and doubling that payload capacity. But ZhuQue-3 is just one of several partially reusable vehicles being developed in China. Another Methalox-powered rocket, the Changzheng 12A, also attempted a landing on its own maiden flight just weeks after ZhuQue-3's debut, but this also experienced an issue during the final landing stage and impacted the ground. That said, we may once again see a second flight within weeks of a ZhuQue-3 flying, so perhaps they'll also stick the landing that time? But wait, there's more! China has even more partially reusable rockets on the way. You may remember Space Pioneer's Tianlong-3 as the one that unintentionally launched during a static fire. Well, this rocket is similar in size and design to a Falcon 9, but it had a less than successful maiden flight, failing around stage separation. So maybe second time is the charm for this one too. A number of other vehicles are planning booster landings by 2028. Galactic Energy's Pallas 1 is set for a late August debut, but won't be attempting a landing until a later flight. Looking even further out, iSpace has been testing its drone ship using a pathfinder of its Hyperbola 3 and could be the first Chinese vehicle to attempt a drone ship landing at sea. CAS Space flew its triple-core Kinetica 2 for the first time in March and is also planning to recover all 3 cores as a single unit in 2028. Now that will definitely be one to see. While we wait, we're sure to see another catch of the Changzheng 10B in the near future, and perhaps even their first booster reflight. Meanwhile, Cosmo Leap plans to catch its Yeqian 1 using a Starship-style catch tower and chopsticks approach, targeting a debut next year. With booster recovery significantly reducing launch costs, there's a lot to watch for as China moves into a new phase of reusability. And if you don't want to miss out on this and other news, you know what to do. Click that subscribe button and ring that notification bell so you don't miss out on our other videos. You might even give us a like to help the algorithm suggest even more spaceflight updates. Well, unfortunately, it's been a cruel summer for NASA's Neil Gehrels Swift Observatory, and the writing's on the wall for the aging telescope. In recent episodes, we've checked in with the observatory and the mission to rescue it, but NASA has now officially abandoned its attempt to save the spacecraft. So what happened? Let's start from the top. The Swift telescope launched in 2004, and since then, it's earned a big reputation for studying some of the brightest flashes in the universe. Many of those gamma-ray bursts result from supernova explosions at the end of the lives of massive stars. Throughout its time in space, Swift's orbit had slowly been decaying, but heightened solar activity in the last few years caused that process to speed up. Without intervention, the spacecraft was doomed to come back to Earth later this year. So in September of last year, NASA awarded a contract to Catalyst Space to develop a spacecraft to capture Swift and boost it up to a higher orbit. That mission, called Link, launched back in early July, but a few weeks into the mission, they knew it was trouble. Following technical issues, Link started spinning. In the following weeks, Catalyst managed to shake it off and regain control over the spacecraft and slow down the spin. Working closely with NASA, the company updated its control software and altered its mission planning to safely catch up with Swift. But this week, they announced that a Swift rescue is now off the table. Link will no longer capture and boost the telescope. Beyond naming ongoing attitude control issues, the exact reasoning for this change of plans has not yet been made public, but it seems that NASA doesn't want to risk things going haywire during capture or reboost. But still, why wouldn't they go for a Hail Mary attempt to rescue Swift? The spacecraft is literally facing its end, so what could go wrong? Well, a lot. If Link loses control during capture, it could bump into Swift, which would certainly create some bad blood by damaging the spacecraft, potentially leaving two uncontrolled spacecraft in orbit. Then, if something goes wrong during or after the boost, it could leave a broken spacecraft in a much higher orbit that takes years to decay. So even a successful capture wouldn't necessarily mean that they were out of the woods. In short, NASA is playing it safe and sound by abandoning the mission. While sad, it's not a completely unexpected outcome. The agency called the rescue a high-risk, high-reward mission. And considering that it was designed, built, and tested in less than a year before its launch, there were just too many opportunities for things to go wrong. These kinds of missions usually take years to develop, so the fact that it got this far is actually very impressive. And it's not wasted effort either. NASA and Catalyst are still attempting to get the most out of the mission, and Link will still rendezvous with Swift and perform proximity operations, which will give them a lot of useful information for future missions. And with all of the learnings from Link, the next potential rescue mission will have a much higher chance of success, even if executed on a similarly tight timeline. But unfortunately, none of that will help Swift. It needs to come down. And once Link's proximity operations are complete, Swift and Link are never, ever, ever getting back together. With no way to boost its orbit, the telescope is now facing its imminent demise and will likely re-enter the atmosphere later this year. Swift is officially in its final era. NASA is now looking for options to continue studying gamma-ray bursts without Swift. Unfortunately, there's currently a blank space where a dedicated successor should be, so the agency may have to steal some time from other missions in the short term. We wouldn't complain if NASA sped up the process for a successor, though. Although Swift stopped most of its science operations earlier this year to prepare for its now-failed rescue, scientists are still combing through the wealth of data that the telescope has collected throughout its life. We got a lot, considering the telescope's mission was originally planned to last only 2 years, and now it's feeling 22. But regardless, it'll soon wrap up its mission to expand our understanding of the universe and our place within it. As for its impending re-entry, look what atmospheric drag made it do. Now we'll turn our attention to the moon and a spacecraft that may finally be getting a successor, or at least some company. The Lunar Reconnaissance Orbiter, or LRO, was launched in June of 2009 on an Atlas V flying out of the Cape. The original mission was intended to last 1 year, but 17 years later, it's still flying an extended mission that NASA has funded through September of 2028. During that time, LRO has been mapping the lunar surface in incredible detail, photographing the Apollo landing sites closely enough to see lunar lunar experiments and rover tracks still there, undisturbed. Its neutron detector revealed evidence of hydrogen, likely water ice, tucked away in permanently shadowed polar craters, and in 2013, it pulled off the first laser communication demo from lunar orbit. This week, on separate earnings calls, the CEOs of two companies that have already landed spacecraft on the moon dropped a significant hint. LRO, it seems, could be getting a successor under the Commercial Lunar Payload Services, or CLPS program. This program enables NASA to buy delivery services from commercial providers rather than building and owning the hardware itself. On August 11th, Firefly Aerospace's Jason Kim said that, quote, "The opportunities ahead of us are 2 lander missions under CLPS 1.0 and then 1 orbiter imaging service under CLPS 1.0 as well." Days later, the CEO of Intuitive Machines, Steve Altemus, described that same opportunity as an orbiter to, quote, "map the moon in replacement of the Lunar Reconnaissance Orbiter, with a task order expected later this summer or in early fall." Now, to be clear, NASA hasn't confirmed any of this, so we don't expect LRO to be going anywhere just yet. That said, a review back in 2022 did flag a risk of it running low on propellant around 2026 into 2027. This procurement is specifically for an imaging service, but LRO does so much more. The craft has a suite of 7 science instruments on board for measuring topography, temperature, radiation, and hydrogen distribution across the surface. None of that is being replaced here. Both these companies are well placed to bid for this kind of task, and the pair already know the moon pretty well. Firefly is already building a commercial lunar imaging service called Ocula, flying on its Elytra spacecraft. These telescopes can pick out details as small as 20 centimeters, that's about 8 inches, from an altitude of 50 kilometers, shooting in both ultraviolet and visible light. This resolution will be sharp enough to hunt for mineral deposits on the surface, and the first Elytra carrying one of these will launch later this year on Blue Ghost Mission 2. It will act as a communications relay for the lander before switching over to imaging work for the remainder of its 5-year lifespan. Meanwhile, you probably know Intuitive Machines from their 2 lunar landers, but the company is also currently operating LRO's high-resolution camera under contract, along with ShadowCam on South Korea's Danuri orbiter. And speaking of Danuri, the orbiter just helped LRO pull off a neat piece of detective work. Just over a week ago, on August 5th, a Falcon 9 second stage slammed into the moon. This stage had sent 2 landers into a translunar injection, Firefly's Blue Ghost and the Japanese Hakuto R. The spent stage then found itself on a collision trajectory with the moon a year later, a path that astronomers had tracked and predicted months before it happened, but we didn't get to see the actual impact. The Danuri orbiter was first to spot a fresh crater on the lunar surface and pass the coordinates to LRO to use its narrow-angle camera for a closer look. What it found was an 18-meter-wide crater, around 59 feet, which is less than 3 meters deep. The stage came in at a shallow angle, around 31 degrees from horizontal, throwing up a distinctive V-shaped spray of ejecta as it impacted near Einstein crater on the moon's western limb. This was technically the near side, but it's so close to the edge that it was impossible to see well from Earth, even though we did try. Between scanning for potential new landing sites and playing crash investigator, LRO is showing no signs of slowing down just yet and is still listed in the budget as an active funded mission supporting CLPS and Artemis missions. And these missions are going to increasingly lean on lunar reconnaissance, so NASA seems to be doing the sensible thing by lining up a successor before LRO's shift eventually comes to an end. Going back to Firefly, this week the company announced how it plans to keep a future Blue Ghost lander alive through the lunar night. The company plans to add a radioisotope heater unit to a future near-side mission under NASA's CLPS program no earlier than 2028. Built by Xenopower, this small passive heater generates warmth from the natural radioactive decay of americium-241, which is recycled nuclear material. The unit will produce 5 watts of thermal power, which may sound tiny, but it's enough to stop sensitive electronics from freezing solid. The brutal lunar nights last roughly 14 Earth days, with temperatures dropping, once the sun sets, to as low as around negative 280 degrees Fahrenheit. That's roughly negative 170 degrees Celsius, which was cold enough to prevent Firefly's first Blue Ghost mission from surviving the whole ordeal. This heater unit is planned to fix this problem, making sure that the hardware is ready to work again once the sun comes back up. And it's the kind of durability that we're going to need as we work towards a sustained presence on the moon. Moving on to a different moon, the European Space Agency's Hera spacecraft has discovered how the dusty Martian moon Deimos was once reshaped by an asteroid impact. The craft is on its way to study the asteroid pair of Deimos and Dimorphos, which were the target of NASA's Double Asteroid Redirection Test, or DART, back in 2022. Hera swung past Mars for a gravity assist in March of 2025 and used the flyby to snap some close images of Deimos using its camera and thermal infrared instrument. Scientists at the University of Bern published new findings this month that use that data to show how one single violent impact was enough to reshape the moon's entire surface, but not enough to break it apart. A relatively small asteroid, around 320 meters across, that's about 3 American football fields, hit Deimos at around a 45-degree angle. Debris from the impact buried the moon under a blanket of dust that's over 200 meters deep in places, leaving its distinct 10-kilometer-wide South Polar Basin. Fittingly, this was a dry run for Hera's real mission. The same impact physics modeling will be used to study DART's impact site on Dimorphos when it arrives there in November. And hey, just last month, Doss and I interviewed DART and Hera team members on Intrepid Museum's Astro Live. It's a great watch, so if you want to learn more about the upcoming Hera mission, be sure to cue it up for when this episode is over. Russia's Soyuz rocket might be in trouble. This week, factory buildings in the city of Samara were hit by Ukrainian Flamingo missiles. Parts of the factory have now collapsed, reportedly a clean room used for assembly of onboard electrical systems and avionics, though Ukraine's military reported hitting the Soyuz engine assembly hall and an aviation equipment maintenance shop. And while those two are very different accounts of what exactly has been damaged, either way, it seems that Soyuz production might be in trouble, and that could mean problems for the International Space Station. The Soyuz rockets are produced by a company named RKT Progress. The rocket is Russia's main launcher, and it frequently launches military payloads. RKT Progress doesn't just build rockets, though. It also produces military satellites, both of which, understandably, could have made the factory a target for Ukraine. Now, of course, Soyuz also launches crew and cargo to the ISS, and on that front, there is some confusion to clear up. As I mentioned, the factory that was hit is owned by RKT Progress, but that has nothing to do with the Progress cargo spacecraft, which is built by a different company, RSC Energia, which also manufactures the Soyuz crew spacecraft. Regardless, both spacecraft rely on the Soyuz rocket for their ride up to the International Space Station, and that ride may now be in trouble. Both Soyuz and Progress serve the Russian side of the station and provide critical functions to the orbital outpost. Progress also frequently gives the station a boost to help it stay in orbit. Despite US vehicles like Cygnus and Dragon, which have demonstrated similar capabilities, the station can't really do without Soyuz and Progress. The Russian side depends on the vehicles, and it's not like you can just split the station up and expect things to keep functioning. Both sides need each other to remain a habitable space station. Though, in the early days of the war, former head of Roscosmos Dmitry Rogozin threatened to do exactly that. But of course, that never happened. The station has remained mostly unaffected by the war and the resulting sanctions and political tensions because, as the saying goes, from space, there are no borders. That could change now, though none of the ISS partners have reported on the situation at this time. Hopefully, they've still got enough rockets to continue regular ISS operations, because for better or worse, we still need to keep this international collaboration going for at least a few more years, or until there's a suitable replacement. Now we'll turn to future spacecraft as we take a look at some other stories across space. The European Space Agency and Atmos Space Cargo are working on a reusable spacecraft. Atmos is building a satellite called Phoenix 2, which is supposed to launch its first of 7 missions later this year. The spacecraft has a payload capacity of 100 kilograms and can stay in space for up to 12 months, after which it will re-enter with its inflatable heat shield. Following recovery, Atmos then wants to turn the capsule around for another mission. But the company also has some even more ambitious plans. Together with ESA, they've been working on a study for Phoenix 3. The version of Phoenix 3 considered for this study is much bigger, with a payload capacity of 1,000 kilograms. It would launch into a 350-kilometer orbit from where its payloads would perform their missions, from science experiments and technology tests involving manufacturing in microgravity. The capabilities of Phoenix 3's final design may change as it gets closer to reality. This was just a study after all, and it's an exciting concept, although concepts don't always go to space. Hardware does. We'd love to see Atmos launch Phoenix 2 soon and show that they can bring these ideas into reality. Another European reusable spacecraft in the works is Nix from the Exploration Company. The capsule is designed to ferry cargo to and from space stations, and it's set to visit the ISS in a few years. They're working to make that happen and regularly show off hardware, including a full-size structural test model, which they've run through a series of tests and are now fitting out with the spacecraft systems for integration tests. Meanwhile, they're also testing parts of the spacecraft individually. Recently, they showed off the test setup for their docking camera. The final approach to a space station can be challenging, as it has to be successful under all kinds of lighting conditions, from the darkness of orbital night to sun shining into cameras at inconvenient angles. To test the cameras, the company built a setup with blackout curtains and movable lights in which they moved around a Nix mock-up towards a 3D printed ISS docking target to test the final approach to the station. They've also been testing the separation of the Nix capsule and its service module. This week, the company announced completion of a test campaign to characterize the shock produced by the separation system. The test included a part of the capsule's thermal protection system to ensure that it survives this key part of the spacecraft's return to Earth. Hopefully, these tests will culminate in Nix flying to the ISS in just a few years. We would love to see it. And from future spacecraft, we go to the missions that recently flew in this week's space traffic report provided by Next Spaceflight. Falcon 9 broke another record this week. The rocket's first mission of the week lifted off from Florida to launch 8 satellites for Globalstar's mobile communications network. While this was just a regular Falcon 9 mission, it set a record in motion, as only 38 minutes and 31 seconds later, SpaceX launched another Falcon 9, this time from California. This was the closest time between back-to-back Falcon launches to date, breaking the previous record by 27 minutes. That second flight launched a classified mission for the U.S. Space Force. Now, obviously, we don't know much about it, but based on mission profiles, it seems like it might have been a batch of satellites based on SpaceX's Starshield platform. The mission's booster, B-1088, flew its 18th mission and was responsible for another milestone. Its touchdown on the deck of drone ship Of Course I Still Love You marked SpaceX's 650th successful Falcon booster landing. Falcon 9 flew 2 more missions later in the week, launching a total of 53 Starlink satellites into low Earth orbit. And on the theme of internet satellites, China launched a batch for its SatNet LEO constellation on board a Changzheng 12. We also had a Changzheng 2C launch an Earth observation satellite for the United Arab Emirates into sun-synchronous orbit, followed by the ZhuQue-3 launch that we discussed earlier. From New Zealand's Mahia Peninsula, Rocket Lab launched an Electron on a mission dubbed The Lightning God Defends. Now, if you're clued into Rocket Lab's naming scheme, that will have given away that its payload was another synthetic aperture radar satellite for Japan's IQPS. Over on the International Space Station, 2 astronauts stepped outside of the orbital outpost to replace a broken space-to-ground antenna. The spacewalkers were NASA's Anil Menon and ESA's Sophie Adenau, who performed her very first extravehicular activity, becoming the first French woman to do so. It was the second for Menon, following one that he performed earlier this month. During this week's 6-hour and 23-minute spacewalk, the duo removed the old antenna, but it took them longer than expected to disconnect cables and loosen bolts. As a result, they didn't have time to install the new antenna. Instead, they're now planning another EVA for next week on August 25th, during which they'll have about 6.5 hours to install the replacement antenna. If time allows, they'll also replace a retroreflector on the station's forward port, which is used for navigation by visiting vehicles. On the launch side of next week's schedule, we've got a moon mission coming up. China's set to launch its Chang'e 7 mission aboard a Changzheng 5, lifting off from Wenchang no earlier than August 24th. The mission will attempt a landing near the lunar South Pole, featuring a bunch of science instruments alongside a rover and a small hopper that will search for water. Meanwhile, SpaceX is planning 3 Falcon 9 missions, all launching Starlinks from both sides of the U.S. One of the missions, launching from Florida, is set to fly on booster B-1067, which will fly its record-breaking 37th mission. Later in the week, we'll also have a European launch with an Ariane 6 expected to lift off from Kourou in its 2-booster configuration. It'll launch a weather satellite for ESA and EUMETSAT into geostationary transfer orbit. As usual, the schedule is subject to change, but we've got just what you need if you want to stay on top of it. Our Next Spaceflight app and website are the best place to go for the latest updates, and it's completely free. And that's your weekly update of spaceflight news. I don't know about you, but I'm Alicia Siegel for NSF, and we'll see you all again next week to recap this week in spaceflight.